Hello everyone and welcome to today's mathematics class. In today's mathematics class, we are going to study how we can integrate this kind of function, okay? So if you have not been following me on this page, I want you to kindly follow. If you have not understood the basic concept of integration, I posted so many work on this topic last year. So you can search through my page and you will see the elementary aspect of it. Now, let us look at this question. When I look at this question, initially, I began to puzzle. I began to look for a way to solve the question. So later, I realized that this problem can only be solved by integration by parts. So substitution won't work here. Now, integration by parts, look at the formula. When we want to integrate function like this is the formula we normally use. We will say uv, okay, minus the integral of v du. So this is the formula which we normally use to carry out this type of question. Now, if I want to rewrite this question, some of us may be confused. They may be thinking because we are having a fraction here, it looks like that this one is a rational form because it's a fraction. Look at it. But let me show you how it will become a product. Integration by part is normally used to integrate a function which is of what? uv. That is what? Product. Just like the way we have it in our differentiation. So in our derivative, when we want to find the derivative of a product, that means uv. So we have a formula which we use. So same way in our integration. Now this one can be expressed as like this. It can be expressed as ln x. This here means what? The roots, which means 1 all over root x. It becomes x is over negative half. Then this gives us the x. As you can see, here we are having a product. So we are going to integrate this one now. Integration by what? Parts. Let's all use this formula. Now let me tell you one thing about this formula. What you must do, first of all, look at what we are going to be looking for. We will look for v. How do you get your v? Is by integrating what we have here. This here. In this kind of function now, we will say let u. Choose any of the two to be u. Make sure you look for the one that will be easy for you to differentiate. Because what we need du to be substituted here. We also need v. And that same v will be substituted here. Then u here, any of the value you choose here will remain here. Now, starting from this now, let us let u equal to the ln of x. So we say let u equal to what? Ln of what? X. So which means this remaining one here will now be dv equal to x raised to power negative 1 over 2. What we do now, we are going to integrate this. So anytime we're having d of any function, so we will what? Integrate. Then this is what? The x here. Because the remaining part becomes the x. So here, we're first of all going to differentiate u in respect to x. We have the u, the x equal to, remember, in our standard derivative, when you differentiate the ln of x, it becomes 1 over what? X. Then here we come here. What we are going to do now, we are going to integrate. Integrating for v here will become, remember, when you are integrating, you are dividing by the power. That is, if I want to integrate x dx, simply means x plus 1 raised to power, x raised to power 1 plus 1 all over 1 plus 1, then plus c. But in this case, since we are looking for v here, we are not going to be putting this arbitrary constant. So this is the standard form of what? Integration. Now we are going to use that same method here. So in doing that, we are going to be having x raised to a negative half plus half, okay? Then all over that same negative half plus what? 1 rather, plus 1. Then this is also saying half, that is 1 minus half. 1 minus half is half, right? Good. It becomes x raised to power half, then all over negative half. Negative half. Now, we are going to take this since this one is a fraction on its own, so 2 we have to go up, then which means our v here becomes negative 2x raised to what? Half. And of course, our x raised to power half is what? Square root of x. Then let us come to this side. We want to get du so that we can come and substitute du in this our formula. Now, what do? To get your du there, we now go, we should cross multiply now. Since we're having 1 over x here, we can cross multiply here so that we can have x du equal to what? Dx. So from here, we can make du the solid formula by dividing both sides by x. Dividing both sides by x. So this one will take care of that. So that we have du equal to what? Dx all over what? X. Good. So we have achieved this one, and we have also achieved this. Now, we are going to plug them into this formula. Then we integrate this other side of it. This one will remain. This will just multiply. We just take u. What is our u? Ln x. Multiply v. What is our v? Look at the v here. Okay, multiply here. Then du. We are going to put v inside here. What is our v? This is v. Then you put your du to replace this du we have here. Now let us go. U is equal to ln x. Okay. Now we have obtained our v to become 2x raised to power 12. So that is what we got there for v. Sorry, negative sign is not supposed to be there. Sorry for that negative sign I put there. So now we are going to place it here. Our u is what? Ln x, which means ln x multiplying. What is our v? This is your v. That is 2x raised to what? 1 over 2. Then minus, we are going to put your v. Your v is what? 2x raised to power 1 over 2. Then multiply du. What is our du? Our du is what? Dx over what? X. Good. Now, let us multiply. This one will remain here. Nothing will change. So we can have 2x raised to power 1 over 2 ln of x minus, take this 2 outside. We have 2, the integral of, we have x raised to power 1 over 2, then multiplying the x all over x. So this here, you see the same thing as multiplying x raised to power negative 1. Yeah, anytime we're having 1 all over x becomes x raised to power negative 1. So we can change this one to become like this. Multiplying x raised to power negative 1. Then we're having our dx. So here we're having common base now. This is a common base. We have a common base, x and x. So in it, this is what we do. We add the power because the bases are the same. So in that case, on this side now, we have here 2x raised to power 1 over 2 ln of x minus 2, the integral. Here becomes x raised to power half minus what? 1, because we are adding the powers. Then dx. Half minus 1, of course, will give you negative half. So which means, let's come to this side. We have 2. Okay, let's work with the integral. Later, we combine it because of space. Let's work with this one. Later, we come and combine this here. So that your integral now will now give us equal to, we're having 2 here. Okay, let's leave the 2 outside. 2 will multiply everything we have. We have the integral x is negative half, because half minus 1 is negative. Then we have the x. So let's go. Because we're having 2 outside here, let's put the 2 there. Okay. Now we're still going to integrate this now. So this is what we are going to integrate now with respect to this x. So we have your integral now becomes, we have 2 into, as usual, become x raised to power negative half plus 1. Then all over negative half plus 1. Then we are going to add constant. Here, half plus 1 is sitting as saying negative half plus 1 is still the same thing as saying 1 minus half. So this will still give us 2 brackets. We have x is equal half, then all over x, all over what? Half. Then plus c. Now, what we are going to do, this 2 will go up the way it happened in the first place. So it becomes 2, or these 2 are here, can even cancel out these 2, okay? Or we just put it this way, 2 into becomes 2 into x raised to the power half plus c. Now let us combine this one. Let us come and combine it with this left side, okay? These 2 will only affect this value here. This constant is an arbitrary value, okay? So we remove that. So these 2 is only multiplying this, okay? It's only multiplying that. Now, we are going to bring this one, combine it with this. So it now give us 2x raised to the power 1 over 2 ln x, then minus these 2 will multiply this, gives us what? 4x raised to the power 1 over 2 plus c. Okay, so I think this gives us the answer. So you can leave your answer like this. But if you don't want to leave the answer this way, what you are going to do, you look at what is common here. You can see that what? X raised to the power half is common. X raised to the power half is common. Are you see that now? And also we have 2 here. We also have 4, which means I can take these 2 out of this word 4. Then in that case, it means 2x raised to the power 1 over 2, then is common. We put it outside, we factor it out, we have ln x. Then if you take this one away from here, it will remain 2. Then we have plus what? C. So this is your answer. I hope you understood this. So if you find this video very interesting, please help us to share this post and do well to like and comment so that we can get to a greater number of students on this platform. Bye.